So strategy number, I think it's number 5. Ironically, although I'm a math teacher, counting has never been a strong point for me. So I hate to ruin the suspense for you in terms of course, 'cause I know the fun part is figuring out which strategy we're going to use, but you can probably guess by the fact that the double angle formulas are listed that we will be using strategy number 5. Okay, how do I know to use that strategy? Because that's a double angle right there. And here's another double angle. 2 theta, 2 times theta means you're doubling that angle. So what should we do? Well, it's always a good idea to put these in standard form, meaning set them equal to 0. And we can do that by adding this to both sides, and that will cancel, so we're left with 0 equals, and now if I add 2 sine 2 theta to this side, we're not going to do anything with these angles here, just like if you're adding 3x plus 2x. The only thing you mess with are the 3 and the 2 to get 5. You don't touch the x at all, so we're not going to touch the sine 2 theta. So we have this, we have negative radical 3 cosine theta, and then if I have negative 3 of these and then I add 2 of those, I'm left with negative 1 of those, so negative sine 2 theta. Okay, so this still looks confusing because we said in a prior video, we said in a couple prior videos that we want to have only one trig function in these problems whenever possible, and we have 2 different trig functions now. We have cosine and we have sine. That's where these come in handy. So if you look at this right here, we can replace sine 2 theta, which is exactly what we're going to do. We will replace sine of 2 theta with its double angle identity. So instead of minus sine 2 theta, we're going to plug in this right here, minus 2 sine theta cosine theta. Alright, so now we can use another one of these 6 strategies, and I want you to look at what we have right there and go down the list, try to figure out which one it is. And hopefully you're able to tell it's actually the very first one, which is GCF, greatest common factor. Because if you look at this right here, what is the common factor that they have in common? They both have a cosine. So let's factor out a cosine theta. And what's left behind when we do that? When you divide this one by cosine theta, you're left with negative radical 3. When you divide this one by cosine theta, you're left with negative 2 or minus 2 sine theta. So now we are in a position to solve this, and I encourage you to try to pause and solve the equation from here. Let's set this equal to 0, because that's where one of our solutions comes from, and then let's set this one equal to 0 as well, because that's where our second solution will come from. Well, this one is not so bad. Cosine equals 0. Here's a unit circle. Cosine is the x-coordinate, and the x-coordinate is 0 right here at 90, and it's right here also 0 at 270. So our 2 solutions are 90 and 270. What's nice is that it's never a bad idea to check your solutions, but we don't have to in this case because we're not going to get anything extraneous like in that other problem. Extraneous solutions only result when you end up squaring both sides, and we're not going to have to do that anywhere on this problem. So let's get sine theta by itself right here, because a lot of these problems involve isolating what you're trying to solve for. It's not isolated right now. Okay, so we have this, and that's equal to radical 3. Now we can divide both sides by negative 2. So we're left with sine theta is equal to negative root 3 over 2. So try to remember from that table that we used in the past, what angle has a sine, ignore the negative for now, what angle has a sine of root 3 over 2? And let's just draw up this table real quick. Definitely something to memorize if you haven't memorized it already. 30, 45, and 60. Remember that the signs count up, so root 1 over 2, root 2 over 2, root 3 over 2. I didn't write root 1 because root 1 just equals 1. So it looks like 60 degrees is the angle we're interested in, but it's 60 degrees in quadrants where sine is negative. So my question for you is, in which quadrants is sine negative? And the answer is sine is negative in the tangent quadrant and in the cosine quadrant. It's positive here, S means sine, and it's positive here, A means all. So our reference angle is 60 degrees. Reference angle is 60 degrees, but 60 in this quadrant. So the reference is what takes you to the x-axis. Okay, so those are both 60. So our question is, what is this green angle right here? That's going to be 180 plus 60. And 180 plus 60 is equal to 240 degrees. So there is one solution. And then our other angle is going to be this one in orange right here. Goes all the way around except for that last 60. So it's almost 360 minus that last 60. And that's going to be 300 degrees, and that's our fourth solution. So this has 4 answers. 240, 300, 90, and 270 are our 4 answers.